Okay, hello, my name is Zetarev Falvi Korniawan from the Computer Engineering class 2034. I'm doing the ComNet pre-assignment of video explanation of the module 7. Okay, so first of all, we just start immediately. What is redundancy? Well, in networking, redundancy refers to the presence of multiple or backup network paths or components that maintain connectivity in case of failure. It ensures like high availability and fault tolerance by providing alternative routes. It's basically like a safe fail mechanism for data transmission when a link or device fails. And then efficiency, yeah, it's critical for enterprise networks to minimize downtime and improve reliability. The goal is obviously again reliability. When one route goes down, so another instantly takes over. Then we have number two, which is what is the spanning tree protocol, and explain types of port roles in STP. Spanning tree protocol. Spanning tree protocol itself is a layer 2 protocol that prevents switching loops, which is the main thing, in the internet Ethernet networks by creating loop-free logical topology. And STP itself elects a root bridge and places a redundant links in the blocking state to maintain the only one active path between the switches. And there's the port roles, which is there are four. There's the root port, the port with the lowest cost path out to the root bridge, and then there's the designated port, which is forward frames toward downstream segments, and an alternate port, which just provides a backup path but remains blocked, and then a blocked port prevents loop formation and does not forward traffic. And and then in short, it's that STP keeps redundancy in place, but makes sure that the network stays loop free and just makes it stay stable, which is what it is. Next, we have number 3. Mention and what is explain the STP rules. So this is a re saying it, and then okay. First of all, the STP follows several operating rules, and there's first one is the root bridge election, which is chosen by the lowest bridge ID. And then there's path cost selection, which is uses STP link cost based on bandwidth, which is the shortest path on the to the root. And there's port state, which is port transitions through blocking, and then listening and alerting and forwarding, ensuring there's no loops during the conversions in itself. And then there's a loop prevention, which is only one forwarding path per segment is active while the other is blocked. And lastly is the topology change detection, which is the STP recalculates the topology when a failure or a new link appears, which is like a self-healing system that maintains reliable communication even after physical changes, so that again to save files and data and stuff. Next is the BPDU guard. What is the function of BPDU guard? Okay. BPDU guard is a security mechanism that protects the spanning tree protocol topology from unauthorized switches. It enables an access port to stop unauthorized switches from affecting the STP topology. When a port with BPDU guard receives the bridge protocol data unit, the switches immediately disables that port. And then this prevents the end user from influencing STP calculation and ensure topology stability and loop prevention. Next, what explain what Ether channel is. Explain what scenario where Ether channel is not recommended to be used, and on the other hand, when Ether channel is very important to implement. Okay, let's go here. Okay, Ether channel, which is a Cisco technology that combines multiple Ethernet links into one logical channel to increase bandwidth and provide redundancy. And then, for example, like instead of a 1 gigabit link, 4 parallels link can act as a single 4 gigabit connection. This design increases bandwidth and enables load balancing, and adds redundancy. If one cable fails, the traffic keeps flowing through the others. So instead of just one powerful cable, there's a separated cable link connection that creates the same effect. And then also, there's a few notes as well. So, recommended between devices that fully support link aggregation and have matching configurations such as speed, duplex, and VLANs. So, essentially, like what I wrote here is for switch to switch or switch to server connections, and not recommended when it's not like aggregation support. And then also according to Cisco and IEEE, the 802.1ax standards is that the Ethernet is a cost-efficient way to scale both performance and reliability without complex routing, which is one of its strong points. Okay, number six is explain what the PAGP and LACP are, and then mention and explain the modes used in them, and explain how they work. So this is the answer. Okay. Ethernet channel can be created automatically using either PAGP or port aggregation protocol, which is what it says, or LACP, which, which is let's start with the PAGP first. Is this one? PAGP or port aggregation protocol is a Cisco proprietary and supports two modes, which is auto, which is response to PAGP negotiation request but does not initiate, or desirable, which is actively initiates PAGP negotiation. And the second one is LACP, which is link aggregation control protocol, which is in the IEEE 802.3 AD, and this stuff standard for vendor neutral link aggression, which is where there's which is also have two modes, which is active and passive. Active, which just sends LECP packets into initiate negotiation, and then passive is wait to respond for incoming LECP packets. And then they both protocol discover compatible ports and bundle them logically, and automatically disable any failed links, which is their use case. And then the idea is to again maintain consistent data flow and redundancy, which is the whole part of this module. Next is lastly number 7, which is write a scenario for configuring Ether channel using link aggregation control protocol, which is LCP, in a situation where there are two switches with multiple connected links. Okay. So here we have scenario 1 and 2, which is this two switches. There's a switch 1 and a switch 2. Okay, for switch 1, we create the interface range of the fast Ethernet port, and then convert the range that the channel group with mode active, and then make a port channel 1, which is switch port mode 2 trunk. And then the other one is switch 2 is on the same under range of fast Ethernet, and then make that into a passive instead. And then that's how it connect. And then by using this active passive negotiation, LCP forms an Ethernet channel automatically, because that's how they work. And then the four links act as a single logical trunk. If one fails, traffic continues on the remaining links, ensuring a load balancing, fault tolerance, and effective bandwidth utilization. Um, yeah, the what's called the disallow. Yeah, this is basically how it works. And then yeah, lastly, this is my references. You can see they basically come from the same thing, which is like some Cisco systems website stuff and some other extra stuff. And yeah, that's it. Thank you for listening.